What makes Tesla rise above the rest? How are they able to sustain their operations, and how can the answer to these questions affect your financial decisions? With their bold plans to achieve 2 million deliveries by 2023 and conquer the mass market, the company is fully committed to revolutionizing the automotive industry. Let's discuss how they plan to do these. Tesla has set its sights sky high with their goal of achieving 20 million deliveries by 2030. This would grant them a resounding 24% market share and secure their position as the leading automaker. To realize this audacious objective, Tesla has meticulously charted a roadmap that includes cutting costs by 50%. By reducing power drain batteries and general assembly expenses, they aim to penetrate the mass market, capturing 50% of the market share. 5 sources with knowledge of the development said Tesla had merged a number of advances into a technological leap that might change the way it produces electric vehicles and aid Elon Musk in achieving his goal of halving production costs. The company invented the Giga Casting technology, which reduced production costs and forced competitors to catch up by using massive presses with 6,000 to 9,000 tons of clamping pressure to mold the front and back structures of its Model Y. According to the sources, Tesla is getting close to a breakthrough that would enable it to die-cast almost all the intricate underbody of an EV in a single piece, as opposed to the roughly 400 parts in a normal car, in an effort to increase its lead. According to the sources, the know-how is essential to Tesla's unboxed manufacturing approach, which Chief Executive Musk outlined in March. It is a cornerstone of his aim to produce tens of millions of less expensive EVs over the next 10 years while still turning a profit. Although Tesla has stated that their unboxed model entails simultaneously generating massive sub-assemblies of a car and snapping them together, the size and composition of the modular blocks are still up for debate. According to Terry Wojciechowski, head of the American engineering firm CareSoft Global, if Tesla is successful in giga-casting the majority of an electric vehicle's undercarriage, it will further alter how cars are created. It's an enabler taken to the next level. It has significant implications for the sector, but it is a difficult process. According to Wojciechowski, who spent more than 3 decades working for American manufacturer GM, castings are very hard to do, especially the bigger and more complicated. According to 2 of the insiders, Tesla could create a car from scratch in 18 to 24 months thanks to previously unknown innovative designs and production procedures, as opposed to the 3 to 4 years it currently takes for most competitors. The 5 individuals said that a single huge frame, integrating the front and back parts with the center underbody where the battery is located, could be utilized in Tesla's tiny EV, which the company plans to introduce by the middle of the decade with a starting price of $25,000. 3 of the sources claimed that Tesla would decide this month whether to die-cast the platform in one piece, albeit even if they do, the final product may vary during the design validation process. The innovation made by Tesla focuses on how massive molds for such a large item are created and tested for mass manufacturing, as well as how casts might include hollow subframes with internal ribs to reduce weight and increase crashworthiness. According to 5 people, the breakthrough in both cases includes 3D printing and industrial stand, which design and casting experts in Britain, Germany, Japan, and the United States created. They all agreed to speak to Reuters on the condition of anonymity, since they are not authorized to do so. The gigawatt dilemma is the reason why automakers have so far refrained from casting ever larger structures. While building molds to create pieces 1.5 meters squared or larger increase efficiency, doing so is expensive and fraught with numerous risks. Changing the design of a huge metal test mold after it has been formed may cost $100,000 per time, or remaking the mold entirely could cost $15 million, according to one casting specialist. Another stated that the whole expense of designing a huge metal mold would be around $4 million. That has been judged prohibitive by automakers, especially given that a design may require 6 or more charges to get a flawless die in terms of fit and finish, ergonomics, noise and vibration, and crashworthiness, according to the sources. Despite the dangers, the sources claim that Musk's original goal was to find a way to cast the underbody in one piece. Tesla went to businesses that use 3D printers to create test molds from industrial sand to get around the challenges. Binder jet printers use digital design files to print a liquid binding agent over a tiny layer of sand, layer by layer, creating a mold that can die-cast molten alloys. One source claims that, even with several iterations, the expense of the design validation procedure with sand casting is cheap, only 3% of doing the same with a metal prototype. That means Tesla can iterate on prototypes as often as necessary, printing a fresh one in a matter of hours with the help of equipment from businesses like Desktop Metal and the subsidiary X1. According to 2 sources, the design validation cycle for sand casting only takes 2 to 3 months, as opposed to the 6 to 12 months it can take for metal mold prototypes. Because they are hollow, the subframes in a car's underbody are typically lighter and more crash resistant. They're now created by stamping and joining many sections with a gap in the center. Tesla intends to insert solid sand cores created by the binder jets within the overall mold in order to cast subframes with hollows as part of the Giga Casting. The sand is taken out to reveal the voids once a part has been cast. Despite the intricacy of the big frames and the increased design flexibility, there was still a significant obstacle to overcome. The casting's aluminium alloys performed differently in sand and metal molds and frequently fell short of Tesla's requirements for crashworthiness and other characteristics. Three of the sources claim that the casting experts addressed this by creating specific alloys, optimizing the molten alloy cooling procedure, and developing an after-production heat treatment. Additionally, Tesla can spend money on a final metal mold for mass manufacturing once it is satisfied with the prototype. The sources claim that due to its planned tiny car simpler underbody, Tesla the ideal opportunity to cast an EV platform in one piece. Since there isn't much of a front hood or rear trunk, the little cars Tesla is creating, one for personal use and the other for robo-taxi, don't have a large overhang at the front and the back. A battery tray with little wings connected to both sides is sort of like a boat, one individual said. It would make sense to do that in one piece. However, the sources claim that Tesla still needed to decide which type of gigapress to employ it if it chose the underbody in a single piece. The decision would also determine how intricate the car frame would be. The people stated Tesla would need newer, larger gigapress with tremendous clamping powers, at 16,000 tons or more, which would be expensive and could require larger factory buildings in order to receive such fast body parts quickly. However, according to 3 of the 5 sources, one issue with the presses using strong clamping force is that they cannot accommodate the 3D printed sand cores required to create hollow subframes. They claimed that Tesla might overcome these challenges by utilizing a different kind of press into which molten alloy may be progressively poured. This technique tends to produce castings of greater quality and can tolerate sand cores, but the procedure takes time. According to rumors, Tesla has developed a breakthrough technology for the so-called Giga Casting method that would enable it to die cast protectively the whole intricate undercarriage of an electric vehicle in a single piece. 5 sources with knowledge of the plans told Reuters that the condition of anonymity that Tesla has integrated a number of breakthroughs to enable one-piece die casting. If the information is correct, we're talking about a significant innovation because in order to construct a frame this size using normal techniques, hundreds of individual parts must be put together. It goes without saying that this might fundamentally alter the way Tesla constructs electric vehicles and significantly help achieve CEO Elon Musk's long-term aim of halving production costs. According to 2 insiders, Tesla's revolutionary design and production methods may enable the business to construct a car from the ground up in 18 to 24 months, as opposed to the 3 to 4 years required by most competitors. The 5 insiders claim that Tesla's $25,000 compact EV, which the firm hopes to introduce by 2025, might be the first time a single huge frame connecting the front and rear sections of the central underbody where the battery is located. That's all for now. For more videos like this, subscribe to the channel, comment your thoughts below, press the like button, and thanks for watching. See you in the next one.